Okay, so we are going to find the area of the region enclosed by these two curves, y squared, x equals y squared minus 9, and x equals 9 minus y squared. So these are really functions of the form g of y equals x, right? Or x equals g of y. So this is going to be a good example of the scenario where we have a left and right function as opposed to a top and bottom function. So first we want to, of course, graph these. So both of these are transformations of the graph of, or the curve, x equals y squared, right? So x equals y squared is just the parabola, fallen over. So this is x equals y squared, right? And then if we want to graph this first curve here, y squared minus 9, then we have just to shift this over, on the x-axis, shift it over 9 units to the left, right? So this is x equals 9, or y squared minus 9, right? And then if we want to graph this second curve, again, this is a transformation of x equals y squared. And so we have that this has a -1 right on as the coefficient of y squared, right? So this is going to flip this over the y-axis, right? So if we wanted to graph the curve x equals -y squared, right, then that would just look like this, right? But we're not done yet, right? We have x is equal to 9 minus y squared. So we have to shift this over 9 units to the right. So it looks like that. Right? So these are our, two curves here and here, right? And this is going to be the -9 right here. Okay, so let's just put this together, right? Graph these actually together, on the same plane. Maybe let's make this a little bit more centralized. So we have, let's do a different color, right? We'll do red for our first curve, which was the x equals y squared minus 9, right? And then let's do blue for the second curve here, which was x equals 9 minus y squared, right? So you see that clearly these two curves are more like right and left curves for this region here, right? Our region is this region here, right? And so what we're really doing is, forming these rectangles that are horizontal now instead of what we're used to as vertical rectangles, right? And so the height is really like this horizontal length, right? So this will be the right function minus the left function. And this is our width is delta y now instead of delta x, right? And so area is equal to whatever this lower y value is, c, the integral from c to d, where d is this upper y value where the curves intersect in this case, right? So, and then xr minus xl, right? So it's pretty, easy to see that the right function is the blue one, right? Xr is equal to 9 minus y squared. And the left function is the red one, which is y squared minus 9. So xl is equal to y squared minus 9. And to figure out, I mean, we can clearly see that the curves intersect at these 2 points, but just in general, you know, we want to find our C and D. Right, these are our intersection points, which are where these 2 curves are equal, right? So 9 minus y squared is equal to y squared minus 9, right? And so there's a few kind of ways you can solve for y here, but you know, we have adding y squared to both sides, we get 2y squared minus 9 is equal to 9, and so 0 is equal to 2y squared minus 18, and you know, dividing by 2, right? So we have at y, well, this is y squared minus 9, so this is when y squared minus 9 is equal to 0, which is at y equals 3 and negative 3, right? You could also just add the 9 and take the square root, but, right, or just y equals plus minus 3, right? So our lower limit of integration is negative 3, and the upper is 3, right? So this is negative 3 here, and this is positive 3 here. All right, so this is this area is the integral from negative 3 to 3 of 9 minus y squared minus oh, and I forgot to do a dy up here, right? 9 minus y squared minus 9 dy. Right? And so all we do here is first we want to distribute this negative, right? Get minus y squared plus 9. And this is integral from negative 3 to 3 of 18 minus 2y squared dy, right? So I'm just going to kind of shift this over here. Right, so we have the integral of 18 minus 2y squared is 18y, right? Minus 2y cubed over 3. We're going from negative 3 to 3, right? So in general, you know, if we're integrating some constant k, in this case we're doing dy, so we'll use that, then that's just k times y here. Right. And the integral of negative 2y squared is just our power rule, right? So, right, so this is constant k. Okay, so then evaluating, we have 18 times 3 minus 2 times 3 cubed over 3 minus 18 times negative 3, right? Minus 2 times negative 3 cubed over 3. And so we have 54 minus, and then this will cancel out at least, so this is just 2 times 3 squared, which is 2 times 9, or 18. This will be negative 54. And then here again, we'll have that these will cancel, but we'll still be left with a negative right out here. So maybe that's not the most clear. So let's just kind of see that what's happening, right? So right, this is going to be negative 2, right, times negative 1 cubed times 3 cubed, right? Negative 3 cubed. Oops, sorry. Negative 3 quantity cubed is the same as negative 1 cubed times 3 cubed, right? So then these cancel out, and you're left with the -2 times -1 cubed. -1 cubed is negative, right? So -1. And then times 3 squared. So that'll give you 2 times 3 squared, which is 18. Right? So this is plus 18. And then we go 54 minus 18 plus 54 minus 18. So that's 108 minus 36, which is 72. And so that is our area. Of course, 72 is a positive number, just as a sanity check. But that is our area of our region here with left and right curves.